Hello, class. I'd like to give you a brief tour of Stellarium and show you some of the features that I commonly use. I'm not an expert user. I think there is a community of people that not only use this software often, but even contribute to it because it's open source. It's an amazing piece of software. I think it's been around for at least 10 years, maybe closer to 20, but it's gone through various incarnations and improved over the years. This software replaces what used to be used. It was called a planisphere, basically a paper wheel with a map of the sky, and it took a little bit of skill to learn how to use it. Normally, in a normal semester, we would also do that, but this is remote instruction, so we'll probably skip that. So this is the modern planisphere. It's the electronic planisphere. Okay, the first keyboard shortcut I would like to bring to your attention is F11. If you don't want this to take up your entire screen, if you'd like to be able to switch between your browser and Stellarium, hit F11. Now, I don't think you're seeing what's happening right now because in Zoom, the Stellarium window is maximized anyway. But right now I'm tapping F11 and switching back and forth between the desktop and the Stellarium window. If you're wondering why they call it Stellarium, well, you know, a planetarium is a dome-shaped room where you go in, you sit in the dark on a field trip with your elementary school students or classmates. Maybe you got to do that and listen to some relaxing voice show you the planets moving around on the dome, the ceiling of the dome. And so stellarium, I think that word root means stars. So it's just a play on the word planetarium with stars. Okay, I see immediately some cardinal directions here. Evidently I'm facing south. And where the heck am I? Let's go down to the taskbar, menu bar, toolbar. Let's call this a toolbar. There's a whole bunch of options here. Many of the things that can be done down here can also be done with keyboard shortcuts. And I actually prefer the shortcuts. It takes a little bit of effort to learn a few of them, but once you've got them, it's more intuitive and quicker to use this program. Over here is where various useful windows, I was going to say menus, but various useful windows are available. Let's check out the location window, which is the very top one. It looks like a little compass that you would see on a map. So where am I? Well, they tell me my latitude and longitude, and I believe I actually went in here manually and adjusted these for, I forget where, but it's somewhere near Los Angeles. Now, you can type in the name of a city. If it's a big city, it's already pre-programmed into this map here. Let's try this one. Let's try Long Beach. Long Beach, there's a couple options. Did you know there's a Long Beach in New York? Let's go with Long Beach, California. And notice how it updated down here. Okay, do I need to hit enter or anything? It looks like it automatically adjusted latitude and longitude. That's cool. Now you can just click on the map. That's not very precise, but you can update your location that way. So you can see that the view of the sky changes, of course, depending on where you are on planet Earth. I'm going to go back to Long Beach. If you type in, for instance, Paramount, that's not going to come up because it's not a major city. Maybe it is in your life, but not according to the world at large. So I'll close out of here. Also, before I do, there's a couple other things here. Your time zone here. Let me say a word about that. UTC, that means Universal Time Coordinate. That is the time in Greenwich, England. That's like the reference time zone. And here's something that might be worth memorizing. In Los Angeles, we are typically 8 hours behind UTC. So if it's 8 p.m. in Greenwich, England, it would be noon here. Except for the time of the year where we put the clocks forward, called daylight saving time. So during daylight saving time, on the Pacific coast, which is called, is it PDT, Pacific Daylight Time? I believe that is. So during the time of the year when we do daylight saving time, we go ahead an hour, which would make us 7 hours behind UTC. So there may be a lab later in the semester where you have to specify, I need to know what your time zone was. And the default option here is just to set the time to whatever the time zone is at that location. So if you want to do a lab using Greenwich Mean Time, which is the time in Greenwich, England, well, that's UTC, you would have to change that in this menu here. Okay. How about the search window? I see a bunch of stuff here. Maybe we should talk about looking around. So the typical coordinates that you would use here are azimuthal and altitude. Altitude, azimuth coordinates, which is exactly how your head works, right? So you're standing on planet Earth. If you'd like to scan the horizon, meaning look left, look right, you do this with your head. You just tilt your head left or right. So on your keyboard, you can use the arrows, left arrow, right arrow, to scan left and right. That's what your, or the coordinate that you're adjusting there is your azimuth. So when you're looking north, that's an azimuth of 0. If you turn 90 degrees to the right, you're now looking east, that's an azimuth of 90. 180 would be due south, 270 would be west, and then we're back to 360, which is the same as 0. Now, when you tilt your head up or down, looks like I'm nodding yes. Yes. No. You know, I never made that connection. When you're nodding your head yes, you're changing your altitude. When you nod your head no, you're changing your azimuth. Now, the alt-azimuth coordinate system can be superimposed on the sky, and the word azimuth has that Z in it. So hit the letter Z, and there's the altitude azimuth coordinate. So, as I mentioned, if I turn east, see this line coming out of the eastern cardinal direction. If I go all the way up to the top, it's labeled as 90 degrees. This is 10 degrees more to the east, 10 degrees more. Eventually you get to 180 degrees azimuth. Now the altitude, that's given by these numbers right here. So every point along this line is 20 degrees above the horizon. I remember those rules that we introduced in a previous lab. We called them the finger rules or the pinky rule. You can hold out your fist at arm's length or the hang loose sign and do a decent job of estimating angular sizes. So I forget, the hang loose sign from thumb to pinky, let's go with the fist because that was easier, 10 degrees for the fist. So if you held your fist out at arm's length, the height of your fist in your field of view would be about this right here. That's a good way to estimate these distances if you're out looking at the night sky and you want to get some idea of how high a star is, for instance, above the horizon. Now, do you remember the name for that point way up over your head? It's not easy to look at that point. The human neck is not really built for looking straight up over your head, but you can do it, and that point directly over your head is called the zenith. So this coordinate system that you're looking at, that's the most natural one for people, because that's how our head works. But I'm going to hit Z and hide that now. And I think I would also like to get rid of these pesky cardinal signs. So Q will get rid of the cardinal signs. You don't have to memorize these. One reason you don't have to memorize it is because they're all in the keyboard shortcuts. So if I go down to Help, or you could hit F1, bring up the Help window, and look at all these keyboard shortcuts. I do not have all of these memorized, but I have a few of them memorized, some of the most useful ones. And oftentimes, I will relearn them if I want to use software, because you can acquire some of those shortcuts in a couple minutes of usage, and then it's in your memory for a week or so. But this is probably one of the most helpful things, is to know how to pull up the Help menu and examine the keyboard shortcuts, which I will do a couple times during this video. Okay, now what's with the grass here? Because I typed in Long Beach. Actually, we're not in Long Beach anymore, are we? Okay, let me go back to location window. Long Beach. Oh, there's the sun. No, where is this in Long Beach? I don't remember. I know there used to be dairies around, like in Cerritos and Bellflower, but where is this? Of course, this is no actual location in Long Beach. It's just a stock photo or image. So if you want to get rid of it, you can do that. First, let me turn off the sun, this pesky sun. Now, why is the sky blue? Well, that's actually a pretty deep question, and I only like 99% or 90% understand the answer. So, but I can tell you this: without an atmosphere, there would be no blue sky. So, if you hit the letter A for atmosphere, you don't have to deal with the scattering of the sunlight. Did you ever think about this? You could see the stars during the quote day if there were no atmosphere. They're always up there. You just don't see them during the day because the sun's light overwhelms the light from the stars, but they're always up there. Okay, now I'd like to get rid of the ground. Take a guess which keyboard button would get rid of the ground. Very often you can guess the letter. So G for ground, and it's gone. Of course, now I can't see the horizon, so I think H for horizon. There we go. The H button will bring up the horizon if you'd like to know where the boundary is between Earth and sky. But for a lot of purposes, even that's unnecessary, because check this out. Let me put the ground back. A lot of telescopes are mounted in a different way. They don't actually move like this and this the way your head does. A telescope that works this way is called an alt-azimuth telescope for obvious reasons. But maybe the more useful telescopes use an equatorial coordinate system. So let me go into the sky and viewing options. Do I want to do that? No, I don't even have to go there. Right, let me get out of here. We'll come back to this. It's one of the buttons down here. Do you see this little icon that looks like a telescope? Switch between equatorial and azimuthal mount. Okay, well I could just tap that button, or I could tap Control M. I'm going to go with Control M. Wait a minute. Let me go back. Right. First, I will hit the letter E. There we go. So Z brought up the azimuthal coordinate system, alt-azimuth, and the letter E brings up this so-called equatorial coordinate system. Where's north? Okay. So you talked about this, I'm sure, in your lecture class, but it is now time to speed up time and watch the motion of the stars. So warning here. Also, you see I clicked on a star by accident and it brought up all this data. If you want to get rid of all that pesky data, just right-click somewhere, and that'll unselect whatever you've accidentally selected. Okay, warning. If you're like epileptic or really bothered by bright flashing lights, be careful with this. Down here is the clock. It's showing us we're in a time zone UTC -7. That's Greenwich, England, -7 hours. And then they're giving us times on the 24-hour scale, so they're not using AM or PM. You just have to subtract 12, right? 13 is after 12, so subtract 12, and that tells us it's 1:02 p.m. And you can see the seconds ticking by. We're given the date, September 30th, 2020. So this is everything you need to know about when now is. When are we in time? And these buttons will allow you to speed up time, slow down time, go backwards in time, pause time. Honestly, I never use these because I prefer the keyboard shortcuts. You should mess around with both, but here's how I like to do it. K, the letters JKL, look at those on your keyboard, JKL. Get familiar with those buttons. That's JKL is in order, reverse time, pause time, and time forward. So check the time down here. Let me hit the letter K. Wait a minute, stop it. How come it's not pausing? I see, I had to click in the screen first. So now that I've clicked in the screen, so I just tapped K, that unpaused time. If I tap K again, it pauses time. Great. Okay, so if you want to pause time, hit K. Now I want to fast forward time. So again, tapping K again will allow time to move forward at the normal rate. If I'd like to fast forward, I tap L. Well, I guess the first time you tap it, it just resumes normal time. Let me tap it again. Oh yeah, now the seconds are flying by. And does that make the motion of the stars perceptible? Nah, I still can't see the stars moving. Remember, everything in the sky is always turning, or it looks like it's turning. Why? Because you're on a giant planet that's turning. And if you could make the time, or the seconds go by, I don't know, 10 times as fast, check that out. Now the motion of the stars actually becomes perceptible. If you tap L a couple more times, I'm going to show you what happens. You probably discovered this on your own. So again, if you don't like bright flashing lights, look away right now. Here's what happens. Ugh. And if the atmosphere is on so that the sun is rising and setting, it gets even worse. Let me tap L. Whoa, yeah, that's hard to look at. So how did I escape from that? I tapped K to pause time. Let me turn the atmosphere off again. Okay, so this is okay to look at. Let me hit K once more. So here's another very useful keyboard shortcut. If you'd like to make small adjustments in the time, hold down Shift first. I'm holding down Shift, and then tap L a few times. See how the seconds are going by faster, but I've made smaller adjustments, so I can be more in control of the time rate, and it's not going to do that crazy thing where, 1,000 years is going by every second. That's really hard to look at. So Shift L is your friend. Or Shift J. So let me pause time now, and I'll make the stars go backwards. Yeah. So you'll never see this. You're never going to be facing north and seeing the stars move clockwise. They're always moving the other way. If you look north and see the stars moving clockwise, well, that means you're dead, because it means something struck the Earth so hard that it got it spinning the other direction, and I'm fairly certain nobody will survive that. But do you notice how the stars all appear to be making circles around this point? That's why this coordinate system is a very natural one, the equatorial coordinate system. I pulled it up by tapping the letter E. If I hit E again, it goes away. But do you see how natural that coordinate system is? The stars all seem to make circles around this pole. What is that pole? Well, there happens to be a star near the pole. It's not exactly at the pole, but it's near it. Of course, that star is called Polaris, for obvious reasons. And this is the point, this is the direction, like if you went to the North Pole and stood there and looked straight up over your head, this would be your zenith if you were at the North Pole, not anywhere else. So it's the direction of the Earth's axis of rotation, which is why the stars all appear to make circles around that. Anyway, this is not a lecture. This is supposed to be a video familiarizing you with some of the main features here. Now check this out. You may have learned in your lecture class that the Earth is slowly tilting. It's tilting in different directions over a cycle of something like 26,000 years. And I think maybe 10,000 years from now, the axis will have tilted enough that Vega will be close to the pole. So let's go to the date and time window, because I don't want to fast forward 10,000 years. That's going to be really hard to look at. So I'll pull up the date and time window. Let's go 5,000 years into the future. So instead of 2020, it'll be 5020, 5020. Doesn't look that much different. Where is Polaris? Oh, good. It's not even close. It's way over here. So things are happening. Good. I've been told that far in the future, Vega will be close to the pole. So let's go even farther into the future. How about the year 10,020? How do I type that? Yeah. No, that's 1,020, so I need an extra 0. There we go. So Vega is, in fact, moving towards the pole. It's really the pole that's moving towards Vega. So Earth's axis will point in different directions. So right now, Polaris is a great star for finding north. 10,000 years from now, it's not going to work at all. You can't use that trick with the Big Dipper finding Polaris to know where north is. That's unfortunate. What else can I show you here? I'll right-click again. Let's use the search window to look for the moon. I can see it right over here, of course, but F3. I like to use F3. If you don't want to use F3, just pull up the windows here. Here we go. Search window. Type in moon. And you see there's a bunch of options here? Well, there's 3. If you hit Tab, you can cycle through those options. When you've highlighted the one that you like, hit Enter. And your view will automatically center on the moon. Okay, here's the next very important keyboard shortcut. If you have a mouse, an actual mouse with a scroll wheel, you can use that to zoom in, but on the keyboard, here's how I like to do it. Hold down Control and use the arrow. So normally up and down make you look up and down. But if you hold down Control first, then the up and down arrows allow you to zoom. And that's a really nice feature. What's with the shadow on the moon? I don't know what's up with that. And now, do you see how the moon is drifting in the field of view? Very slowly, it's drifting out of view. That is because of the Earth's rotation. So if you'd like to track the moon, as long as you've selected it, see how it says moon, that means I'm currently highlighting the moon. Hit the space bar, and it should restore it to the center of your field of view. Good. Okay. Now check this out. I'm going to speed up time, and let's watch the moon do its thing. The ground's in the way. Let me hit G to get rid of ground. And do you see how it's wobbling? That's where I need to fix my camera mount. So let me pause here. I'll zoom out. Let me restore the ground. Okay. So let's switch the camera mount. I'll click this button, or I'll do Control M. And at first it looks like it's tilted. Well, if you're tracking something that's orbiting the sun, very often it's a better idea to use a camera mounted with an equatorial system. So how about I go north? Okay, yeah. Now I'm going to use the arrows, left and right arrows. Do you see that as I hit left and right, I'm actually moving around one of those circles? So I'll pick this one right here. It looks like I'm kind of scanning my view along this circle. Totally different from the way your head works, but very convenient for this equatorial coordinate system. If I hit up and down, I'm moving along one of these lines. These blue lines here are like latitude and longitude on the so-called celestial sphere, which I know you've learned about in lecture. And they have special names that we don't call them latitude and longitude. They're called right ascension and declination. Usually you don't need to know that for your lecture class, but they are like latitude and longitude on this imaginary sphere. And for a lot of purposes, that's a better coordinate system than the alt-azimuth system. Okay, but let's go back to the moon now. And now, since I've got my telescope mounted in the equatorial system, when I speed up time, let me get rid of the ground. If I speed up time, I don't get all those wobbles, and we can watch the moon go through its phases. You can also see this phenomenon called libration, where the moon appears to wobble. I believe that's called libration. And people have found that fascinating for a long time, astronomers, because it's not something that you would casually notice. Notice how we're always looking at the same side of the moon? We don't get to see its backside. You'd have to go way out there and go around the moon to see that. Or just pull up a video on YouTube. Okay, can we look at something else? How about Jupiter? Let me type in Jupiter. And I'll zoom in now. I think if you hit enter, is it enter? I forget. Oh, backslash. It'll take you right to it. And check that out. They actually show us Jupiter and the four most prominent moons, the so-called Galilean moons. And we have a lab coming up based on the motion of those moons. There's a lot of detail here. Look at that. They're actually showing us the shadow cast by Ganymede. So the sun's rays are coming from over here, and they get blocked by Ganymede, and Ganymede casts a shadow onto the surface of Jupiter. And if I speed up time, you can watch Jupiter turn, you can watch the moons go around, you can even watch that shadow move. Well, watch when the backside of Jupiter comes back into view. You'll see that shadow is gone because Ganymede is in a different position. So it's in a different place. Or that's the shadow from Io. So all of these details are accurate because it's not that difficult to compute where the moons will be at any time, and hence where their shadow will be. These are all real things that you might see if you looked at Jupiter through a telescope. And that's something you can do, believe it or not. You can pull up, a Sky and Telescope will do this for you. You can pull up schedules of when the various moons transit Jupiter and when they cast shadows, and actually see that through a large enough telescope. And if we weren't doing remote instruction, we could be doing that on campus, which some of you might enjoy. Okay. There's a couple other keyboard shortcuts I'd like to show you, and then we'll be done with this for today. How do we reset everything? Is there a way to just reset? Let me just zoom out. I'll hit G for ground. Where is the ground? I see. Okay. Control N will fix my camera mount. And I'll put the atmosphere back in. Okay, let's just say we'd like to speed up by a couple hours, right? We know that the sun makes its way from the eastern horizon to the western horizon every day. How do I go forward just 1 hour? I think I know, but I'm going to check the keyboard shortcut. So I go down to the help window, and some of the most useful keyboard shortcuts are right here. Or we're here. Nope, not there. I must have skipped them. Here we go. Date and time. I find these the most useful. if I just want to go ahead 1 solar hour, I have to use the plus and minus signs, but with the control button. What if I just hit plus and minus? See how they're calling it equals, but when you look at your keyboard, equals and plus are on the same button. So basically it's the plus and minus buttons. Those will allow you to go forward or backward by 1 day. If you hold down control, then it will only be 1 hour. So let me try the hour first. I hold down control and I tap the plus sign. And sure enough, the sun moves forward 1 hour. So I'm just tapping plus. If I want to go backwards, I do control minus. So let's bring the sun back to where it starts at the day, towards the eastern horizon. So that's pretty cool. Now what if I want to go ahead 1 so-called solar day? So now I'm not going to change the time of day. I'm going to jump ahead 1 day just by hitting the plus sign. So note the date here. Right now it's November 25th, far in the future. So let's watch this change to November 26th. Yep. And if you'll notice, the sun is in a slightly different position on that next day at the same time. That's kind of interesting, right? If you go out at 12 noon every day, the sun's not actually in the same position. The motions are a little complicated. I believe you can go forward and backward by a week by using the bracket buttons. Those are the buttons just beneath plus and minus. Yeah, see the date here? It's jumping ahead 7 days at a time. That's a nice way to rapidly move through the year without having to use the fast forward button, because that'll give us seizures. There's got to be 1 or 2 other things I should cover here. Yeah, we need to look at the one option in your lab handout that has changed, because Stellarium is often being updated and they change the names of the menu options. Here's something that's not in your lab that you might find interesting. If I go down to the configuration window, is that it? Nope, that's not it. Sky and viewing options. A lot of the interesting things you'd like to do are in this window. These are all called windows. Aha, so currently the sky tab is highlighted. SSO, that is Solar System Objects. In fact, that is one of the major windows that's changed. So in this lab and a future lab, they're going to refer to a menu that no longer exists. If you want to do anything with the planets, you will either use keyboard shortcuts or this window. SSO means Solar System Objects. That includes the planets. DSO, that's Deep Sky Objects, not dark web, or, well, that's not even the same. Deep sky objects like faraway galaxies, quasars. So here's where you would go for anything to do with the planets. You would go into the Sky and Viewing Options window, click on the SSO tab. But in the Sky window, there's various ways of, think about it, you're looking at a two-dimensional space on your screen, right? How do you take space, which is three-dimensional, like you can think of it like you're standing under this giant dome, and then squash that onto a screen to make it realistic? That's called a projection. And there are various ways of doing that projection. The default here is the stereographic, but check it out. If you click on orthographic and close out, let me get rid of the atmosphere, you get to look at, it's almost like the celestial sphere, is it not? Yeah, it's like you're looking at the celestial sphere from the outside. And if I tap L, you can watch the stars turn through the sky. Remember why they're doing that? They appear to do that because of the Earth's rotation. And you can see the pole there. That would be the north celestial pole. So I really like this option. I'm just using the arrows to do this, and then control up and down to zoom in and out. But that really is a nice way of visualizing how the sky turns. Don't forget, it's really because of the Earth's rotation. I love this option, the orthographic projection. We're not really going to use that. So I'll go back to Sky Viewing Options, restore the usual projection, stereographic, stereo. And that's all I need to say about that. So let me pause and pull up the PDF of your lab handout. So here I am on the 7th page of your Using Stellarium lab handout. You'll notice, for whatever reason, they've got a number 43 down here. So it's labeled 43, but it's the 7th page in your lab. And they ask you to pull up the view window. Remember all those windows on the left side of Stellarium? There actually is no view window now. It's got a different name. There's no sky submenu, or is there? We'll find out. Check the boxes next to show planets and show planet markers. This stuff has changed. So you have to figure out the new way to do it. Notice they're telling you can also turn planets on and off by just pressing the P key, which still works. So let's find out if there still is a view window, and a sky submenu and all this other garbage here. All right, move the mouse over to the left. I don't see a viewing window or a view window, but I do see a sky and viewing options window. That's how they refer to it now. Okay, so there is a sky tab or menu, but I don't see options to turn on or off the planets. Again, that is no longer in the sky tab. That is in the solar system objects tab. Show orbits permanently. Okay, let's see what that's all about. Aha, they're showing us the orbits of the various planets. That looks a little cluttered though, so I'm going to get rid of that. So there's a bunch of options here. You can actually make the moon look bigger. That's kind of fun. I think the largest you can go to is 25. And this always reminds me of that movie 300. I don't know if I've even seen that movie, but I have seen... Okay, it doesn't go up to 25. I have seen a screenshot of that movie where the moon looks enormous. They do that a lot in movies. Make the moon look bigger than it actually does look. Because it's fun. Now, labels and markers for the planets. I guess if you drag this bar around, you can adjust how many of the planets and other solar system objects are actually labeled. But you can do that with the keyboard shortcut P. Okay, that ought to be fairly... Maybe 20 is the limit. Let me just type in the number 20. There we go. Okay. And now, where's the moon? F3, moon... Oh, it's below the ground. Whatever, I'll just get rid of the ground. Whoa! I think my application's freezing out here. It must be running low in memory. But you can see how much larger the moon looked. Okay, as for planets, so there's Saturn. Yeah, it's starting to hang up. Oftentimes you'll have to just close out of Stellarium and reopen it. Remember, if you want to close out from within an application, you can hold down Alt and then hit F4. But since I've got Saturn in view, let's take a look at that. I'll zoom in. They show you the rings, they show you the major moons, and again, that's accurate. The relative sizes are accurate. What happens if I hit the letter P for planets? They just go away. Okay, so you can turn the planets on and off. That's really it for this lab. That's more information than you needed. You can close this video out now, but I'll show you one more thing if you're curious. Are you a Sagittarius, a Cancer, an Aquarius? Have you ever wondered what's up with those names? You know, why, if you were born in December, why are you a Sagittarius? Well, let's try something. I'm going to enter your birth date, roughly, if you were born in December. Now, I was born in the early 80s, but you guys, I think most of you were born in, what, 2015, 2016? Okay, not quite that. Let's go with the year 2000. Let's say you were born in 2000, December 15th, and you're a Sagittarius. Why are you a Sagittarius? Well, let me get rid of the cardinal signs here. Let me get rid of these, and I'm going to type the letter R for artwork. R for artwork. Those are all the constellations. Now, if I tap the letter C for constellation, it puts in the stick figures. That's cool. Let me get rid of the artwork now. It's a little cluttered. So C for constellation, stick figures. I think it's the letter V as in Victor for the names. Okay. And B for boundary. B for boundary will show you the boundary between the various constellations of the sky. They're like the states, right, of the United States. And then one more thing I'd like to do is pull up the ecliptic. If I go into sky and viewing options, sky, is it sky or SSO? Well, you know what, it's going to be keyboard shortcuts. So I'll hit F1, and there's an option in here for turning the ecliptic on and off. So ecliptic line is comma. Right. Okay, so this is the path traced out by the sun throughout the year. Let's check that. Where is the sun? It's nowhere to be found. Is that because I turned off planets? Yeah. Maybe you're thinking, hey, the sun's not a planet. Well, it used to be considered a planet because a planet, that word literally means anything that wanders against the background stars. Okay, so let me speed up time. Oh, turn off the atmosphere first. The moon's ridiculous because I scaled it up by a factor of 20. That would be awesome. But you can see that the sun is steadily making its way around the ecliptic. See how the days are flying by here? It's going to take a whole year for the sun to make one circuit around the ecliptic. And this is something well known to ancient peoples because they didn't have an Xbox or Netflix or Hulu. And they saw the sky every night and there wasn't any light pollution. So everybody was hip with what was going down in the sky. And they knew from observation that the sun, well, you can't see the sun at night, but they were able to infer, the sun's in the opposite position at night than it is during the day. So that they were able to infer that the sun was moving around the ecliptic throughout the year. And I've already messed up the date. What was it supposed to be? December? So if I go back to December 15th, where is the sun on the day you were born in 2001, if you're a Sagittarius? Well, it's not in Sagittarius. It's in this Ophiuchus, which is close to Scorpius. So why aren't you a Scorpio? Oh, surprisingly, it's close to Sagittarius. That surprises me. I thought it was going to be more off. Because to my knowledge, the reason you might be called a Sagittarius, let me go with the 19th, because I know that's actually a Sagittarius. Yeah, on December 19th, in modern times, okay, the sun actually is in Sagittarius. Let's pick a different one. Oh, darn it. I don't even know what month like a Cancer is. Okay, let me just give you the scoop here. Most of you will find, if you're Aries, you'll find that on your birth date, the sun is not actually in Aries. So that might lead you to think, what's the reason for that choice? It's because when this system was put in place a couple thousand years ago, the whole astrology thing, this is not Astrology 101, this is Astronomy 101, but thousands of years ago, the sun actually was in the constellation that your astrological sign is. So let me check in the year 0, or year 1. There is no year 0, strangely enough. It goes from 1 BC to 180. Okay, so the sun is definitely in Sagittarius in December 2,000 years ago. And if you check where the sun is on your birth date 2,000 years ago, you will find that it's in your astrological sign. Maybe even go with 1000 BC. I forget which year is best. Okay, that's for today's tour of Stellarium. That's more than enough information to do this first lab. And I think this is going to be more of an issue in the next lab. But if they ask you to list all of the options in a menu, for instance, if I go back to sky and viewing options, you can change which culture. Star lore. So we're using the Western names for the various constellations. I'm going to go with Norse. I think that's like Norway, Sweden. Let's see how they named their constellations. So instead of Big Dipper and Little Dipper, we've got man's cart and woman's cart. That's so sexist. I'm offended. So that's amusing. And if you look up all the various cultures, there's some surprises in there that are kind of fun. But my point was, in this lab or the next, they're going to ask you something like, name all the cultures listed in these star lore options. That's stupid. You don't need to name all of them. That's just busy work. So, pick 5. Pick 5 interesting ones. That's what I'm looking for. I just want to see that you spend some time getting familiar with the software. It's just an excuse to have fun with it and familiarize yourself with some of the options. You don't actually need to list every option, okay? Just use your best judgment. And that is all.